return to and protect to make our custom stack executable. Then we execute the code injection. Or even we can use the ROP shellcode directly, like the example below in previous, because now in our custom stack, we can have any byte value, including null byte. So we can use on strategy, we have to resolve the libc address at the runtime. So to resolve the libc address, it's randomized, but the good news is the offset between two functions is always a constant. At the runtime or at static by passing the libc header. So we can calculate any destination address from a null address in global offset table. And the good news is ROP gadget is available on most binary to perform that. We can show there will be two techniques can be used. One is God overwriting, this is the most powerful, and another one is God dereferencing. We will show it later. This is your favorite method to exploit format string bus. 3 steps. First, we load the offset into a register, then add the register to a memory location, here the God table. And we call the PLT entry corresponding to execute the new function. In our vulnerable binary, we can find there are 3 gadgets. First is pop ECX to load the offset. The second is pop EBP to load the address of global offset table entry, and then add it together. Let's see how it works. Because there is a leaf, a trailing leaf in the second gadget. That is pop in the first gadget, pop ECX, EBX, and leaf. So after a leaf, our control will switch to a new stack frame. So if our stack is randomized, that gadget cannot be used because you cannot control the next frame, next stack frame with randomized address. But luckily here, the address, the stack address is fixed. We know it in advance, so we can bypass that problem. And we had the pop EBP to point to the new frame, then pop ECX with the offset value. Here is the offset value between printf and execve. The next value is unused. Next, we pop the EBP with the printf in the global offset table and minus some constant. Next, we add the value in the ECX to the memory location, here the GOT table. Pop EBP is unused. Then we call the printf in the PLT entry, and now it is pointed to the execve function. So that's how the GOT overwriting works. And it is very powerful because you can override once and use many times. The GOT dereferencing is similar to the GOT overwriting, but instead of to write to the memory location, to pick the value from the memory location, add it to a register, and connect or jump to that address. This is similar, but it cannot perform many times. When you use each time, you have to set up this sequence again and again. So this is very similar to previous slide. Let's skip it. Okay, now we have on the theory. We have the fish stack. We have the payload loader. And we know how to resolve the runtime address. Now, let's put it on together. There is an assumption in our previous slide that there is string copy inside the binary. So here, if there is no string copy in your binary, you can turn any function to be the string copy to load your gadget, to load your payload by utilize the technique got overwriting, and we see previous. In large binary, we can find some useful gadget without the trailing leaf like this. So you can use this directly to transfer your payload. This will transfer 4 bytes a time. You load the value, the address, add it together. So, how about the practical gadget catalog? It seems that return-oriented programming is missed. So people make the exploit manually, and lots of gadgets have to find it in the binary. But here, with our technique, you can say that it's less than 10 gadgets for practical exploit. What you need is the pop register to load the value, add or sub can be used, a register to a memory location, or an optional add or sub memory location to register. The first one is for got overwriting, second is for got dereferencing. And our ROP automation, simple step, there's 3 steps. First, it generates the gadget for the vulnerable program and search for required gadget to perform got overwriting. Then generate the sample stage 1 payload, transfer it to the payload loader to generate the stage 0 payload and launch the exploit. So the proof of concept tool called ROP, return-oriented exploit, is easy. It can generate the gadget for binary, search for specific gadget, sample stage 1, stage 0 payload generator. We'll see a demo right after. Yeah. First demo for the ROP, and the second is a real-world exploit, a lip-tip buffer overflow. And it's the exploit will perform on the Fedora 13 with the ASLR enabled with ECE. There will be no string copy in the binary, and we will turn the straight compare to the string copy. Let's see. Okay, so we have the ROP ROP shell, interactive shell. Simple command, generate, load, and search. Here we have the vulnerable program, generate vulnerable with the depth of 4. Okay, we have 87 gadgets, some duplicate for the different offset. We can search for, let's say, the pop EBP. So you can have some duplicate gadget. In case in the input there filter, we can choose different address. We can search for wildcard. So pop, you can see here, pop EAX, BBX, yeah. Move. Okay. We can search for add. So here we have the add ABP. Oh, sorry. ABP, ECX, pop ABP. The gadget we want. It's simple. Huh? Okay, now the exploit for the vulnerable. We had the exploit. Here we make a call to ROP payload. Yeah. Then necessary gadget address, pop ECX, pop EBP. We choose the custom stack address is 9410. Our target is the get UID function. We override with the set UID function to turn to restore back the effective UID. Then override the the entry of ECE get UID with ECE. Yeah. Accept the bin cell, and finally generate the state 0 with the string copy function. And launch the exploit. Let's see. Here, the vulnerable. Okay. So, exploit reliable, smoothly, no guess, no brute force. We will see how the difficult to bypass that on Fedora 13. Might take a while. Wow. Okay. Yeah. So you see here, stack address is 19 bits. Heap, share library. So you see non-executable also. So with the default enable, we can have the exploit. Another exploit is the tip info. Here we have the use bin tip info. It will inject BC and a proof of concept. We inject the BC program, and we see it in action. Actually, there is no string copy. So, string K compare, lost, string K compare, call. Okay, back to